Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of similar proportionality. This is standard 8.3a in the great state of Texas, and we are using item number 6 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got two similar triangles formed here. So we've got a little one right here that looks like it is 3 and 6 right there. Then we've got a much larger one, but it is similar, so we can find the proportions here. Looks like it's 18. And then we don't have the height, right? They just give us an h, but that doesn't matter. We can still use that. So what we need to do is we need to find one proportion that works, right? So we need to be matching up similar sides. So let's see what we have right here. So we've got 3, look at F. So 3 over H, right? So they are matching up the width of, or the base of one of the small and the height of the big. And I could just tell you that's not going to work. Right? You can match up two measurements within the same triangle, like the 3 and the 6, or you can match up the base and the base. But what you can't do is you can't just go across and do the base of one and the height of other, because those two don't match. It has to be either within the same triangle, like the 3 and the 6, or the same attribute on both, so like the 3 and the 18. So we'll just go ahead and just cross that one out. Let's just keep moving. All right, so look at G. So we've got 6 over 3, okay? So what I've got here is I've got the height on the small and over the base on the small, okay? So since I'm staying within the small on this first one, what I want to do is I want to do the same thing on the big, right? I want height of the small, so I want to start with the height of the big, H, and then base of the small, so I want to go base of the big, and that's 18. All right, so that's looking good. That's exactly what we have. So G looks good. Let's see what we have for H and J. Those should be wrong. Okay, so let's look at H. 3 over 15. All right, so where is 15 coming from? I mean, you can subtract 18 minus 3 makes 15, but I'm not sure why you would get that. Even if you solve this proportion right, this is at times 6. Maybe they... No, that's going to be 36 if you really wanted to figure out what H was. Okay, so H is wrong because I have no idea where 15 comes from. It's not there. So G is looking good. Let's check out J and hope that is incorrect. All right. So I have got 6 over 3. Okay, so that's exactly what I had on the first proportion, right? So I had your height of the small over the base of the small. So then we need to do the same thing on the big, right? Since we had height of the small, we need to do height of the big over base of the small. So we need to do the base over the big because the two heights need to match. The two bases need to match, which that's what we already have on G. But look what they did right there. They actually flipped it. So that's what we should have, but they actually gave us a 6/3 equals 18 over H. And that doesn't work because the 6 doesn't match up with the 18, and the 3 doesn't match up with the H. And so that's not going to work either, even though that's the only other one that actually uses, correct information in addition to the F right there. That's not going to work. If they were to flip this, invert it, you could actually make that one work, but that is not it. So our answer here is going to be the only one that actually works. It's going to be this is 6 over 3 G equals H over 18, because what they're matching is within each fraction you have the same triangle, and it's the height over the base, G.